Okay, let's start taking a look at this stuff. Like I said, today's stuff is not as terrible as yesterday's stuff. Basically, just looking at tables, calculating stuff from tables. So they're going to be called contingency tables, is what we're going to be looking at. So they're basically just tables that are going to take multiple categories and split things up by category. So like male, female, blue eyes, brown eyes, that kind of thing. Just splitting things up by categories. So that's the main thing we're going to look at. There's also a weird paradox or phenomenon that sometimes happens with these contingency tables or with data. So it's called the Simpson's paradox. It is not named after Simpson College, unfortunately. So it's just named after some guy with the last name Simpson. So it's basically a situation where the total results aren't actually the same as the individual results, okay? So it says like opposite conclusions can be drawn from the same data depending on how it's divided, and I'll show you an example of that here. So it's basically like opposite things are happening compared to what actually should be happening. So that's why they call it like a paradox or a phenomenon. And then it kind of comes from this confounding variable. Confounding variable is like a variable that's not something you're actually looking at, or like it's not something you're studying, but it's going to have an effect on the things you are actually looking at, and it's going to kind of not necessarily mess up your results, but it's going to affect your results and kind of switch it around a little bit, okay? So the example that the book has for this Simpson's paradox is there was a thing back in the 1970s with Berkeley College where they were being sued for discrimination. So basically they were like, hey, you're not accepting women as much as you're accepting men at your college, and they were suing Berkeley College. So the totals and where they were getting this information that was like printed in the newspaper or whatever is said that 44% of men were accepted for the programs at Berkeley, but only 34.5% of women were accepted. So obviously that kind of pissed the women off. They're like, whatever, you're not accepting us as much. But that actually wasn't necessarily true. So the totals show that. So the totals show that 44% of men were accepted and 34.5% of women. But the reason that happens is actually based on what major they chose. So like here they kind of took, so this would be like a contingency table where it's kind of broken into sections here. They took it and split it by major. So what was printed in the newspaper was just those pieces of information. But if you actually go back and look at the people that were admitted, there's actually more categories here that the women admittance numbers were higher than the men's. But this number is a little bit skewed here because the amount of people that were in these categories where there was like a higher admittance rate were bigger numbers compared to here. So like say, like these majors here, maybe these are easier majors and maybe these ones down here are like harder majors. Well, if it's an easier major like art or, something like English or something like that compared to like a doctor or a lawyer, you're going to accept a lot more people into the art program probably than like the lawyer program, right? So here in the men's group, there was more people applying for the one where there was higher acceptance rates. So like, yeah, more men were getting in, but they were also applying to the ones where more people were getting in compared to the women. Well, there was barely any people applying for those majors, and more women got accepted into those. Where like these ones down here are harder majors, so like C and, or not C, I think it's maybe, I don't know, whichever one's like this one here, so 6 and 7. So like this must be a pretty hard major to get into because obviously like only 6% of people got in and only 7% of people got in, but more women were in that one. So based on the major that you picked, that kind of skews the numbers a little bit. So the major is a confounding variable because it's not something they're actually looking at for acceptance rate, but it skews the data a little bit. There's a much better example that's like a baseball example with Derek Jeter and some other guy and batting averages that makes a whole lot more sense. But I had it as the example here, and then it's actually one of the questions on the assignment. So then I'm like, well, shit, we can't do that. So there's a better example on the assignment that's like baseball averages that you can see it better. This one's not the best example, but they only had so many in the book to choose from. So that's why I use this one. But basically, it's just the numbers are skewed because of some other outlying variable of some kind. Okay, well, let's look at the examples then. Like I said, this stuff's really not too bad here, just reading charts. So the first one here, we've got a Titanic example. So it says we're supposed to use Titanic Table 1. I've got the tables on the back side of the packet there, so you can kind of flip back and forth to the tables. And then it says we're supposed to round each answer to the nearest percent. So the general idea with this Titanic stuff is they were looking at like survival rates and seeing if like the poor were less likely to survive the Titanic disaster than the rich people, because obviously the rich people, were able to get out first and that kind of thing. They broke down those numbers and they're kind of comparing that. So it says out of all the people on the ship, what percent died? So if we flip over here, okay, so there's 3 different tables here. They're all actually the same table. They just, each one kind of throws some different stuff here. So like all of these numbers are the same, but here they throw some percentages on here. And then this one, they throw some percentages and some totals there. That one's got some totals there. They just kind of throw some extra stuff there, but this base one is what we can look at here. So it says out of all the people on the ship, what percent died? Well, if we need to figure out how many people are on the ship, all of these groups are people on the ship. So you would just add all of those together. So I would just take like the 203 plus 122 plus, and then just add all those up. 8 plus 528 plus that plus 673. So total people on the ship, we've got 2,201 people on that ship. And then out of all the people on the ship, what percent died? So the people that died would be all of the people across here, right? So you would just add all 4 of those together. They actually total that one down here for the amount of people that died. So we could just use that value there, so 1,490. So when we're doing percentages here, it's kind of inconvenient that we got to flip back and forth, but we would do the people that died. So that was the 1,490 divided by the total people on the ship was 2,201, and again, those are just total numbers. And then I just divide those out, so 1,490 divided by 2,201, and what they want it to the nearest percent, so this would be like approximately 0.6, that would round up to like 8, so that'd be like approximately 68% people died. Okay, and then B, what percent of passengers in third class died? So again, it's kind of unfortunate we got to flip back and forth here. But third class passengers that died, so I'm not 100% sure. It might actually be this number here. But here was our third class passengers. Here was our total passengers in third class, and they only care about the ones in third class. So it would just be that number out of that number. So 528. Out of the total in third class was 706, and then you just divide that out, so 528 divided by 706 is like 75-ish, so 0.75 or 75%. And then the last one, what percent of passengers in first or second class died? So we'll want to combine our first and second class numbers. So first class numbers were 1, and then what died, right? Yeah, died. So 122, second class, 168. So we'll want to add those 2 values together. And then we'll also want to add our 2 totals there for the first and the second class. So go back here. We'll want to add the people that died in first class, which is 122, plus the people that died in second class, which is 167. And then you'll want to add together the total amount of people in first and second class. So 325 plus 285. And I'll just tell you what my sheet says. So my sheet says I got 0.47-ish, which would be approximately 47%. Something like that. So, like I said, just reading the tables, picking out the specific things, seeing what they want for totals, if they want it total like everybody on the ship or total per category, just being careful how you read this stuff, basically. They give some other examples here, too. So, this next one here, it's in the lesson, and it's also on the back page there as well, so you can either look in the book or flip back and forth again. So use the data from exercise 2 in the lesson to answer to the nearest 1/10 of a percent this time. So what percent of people in the study did not have a tattoo? So here they're looking at people that have tattoos, don't have tattoos, if they got it done at like a place they're supposed to, or if they just got it done in a prison or somewhere random, and then if they have hepatitis C or not from that. We're missing a couple totals here. It might be helpful to fill those in. So like here, if they didn't give us the totals for tattoos done elsewhere or whatever, we could just add those two together. So like 53 plus 8 is 61. And then 18 plus 495 is 513. And then all three of those added together for this total would be that one, and that one. I've got on my sheet that that's 583. I think we're going to need some of those numbers, so that's why I filled those in. Okay, so the first one there, what percent of people in the study did not have a tattoo? Okay, so the people that did not have a tattoo is all of these guys. That totals 513. Total people in our survey was, or in this study or whatever, is 626. So I'm thinking there that's got to be the 513 out of 626. And then if you just calculate that out, 513 divided by 626. What do they want us to go to? The nearest tenth of a percent, so that would be 0.819, and then that would be approximately 81.9% of people in the thing didn't have a tattoo. B, what percent of people in the study with no tattoo had hepatitis C? So now we're only looking at the no tattoo group, which that total was 513 because we just used that one. And then we want those people that did have the sickness or disease. So did have it was 18 out of the 513. So 18 out of 513. And then just divide that, which is a pretty small number. I've got 0.035, which would be approximately 3.5%. And then C, what percent of people in the study with a tattoo had hepatitis C? Okay, so with a tattoo, there's two different groups for that, because there's the ones that got it done at an actual place or just in somebody's basement. So I think we're going to want to combine these two groups together, and they want the ones that did have it, right? Had hepatitis C. So we're going to combine that one and that one for the top, that one and that one for the bottom for our totals, for all the people that do have the tattoos. So it'd be like 17 plus 8 for the ones that have the sickness, out of 52 plus 61 for the total people that got them. And then we'll figure out what that's approximately equal to. So that'd be like 15 divided by, what is that, 113? No, not 15, 25 divided by 113, which is like 0.221, so approximately 22.1% for that one. And then for part D, what can you conclude about your answers to part B and C? Okay, well, those were the people that had hepatitis C, whether they had a tattoo or not. So what do you think? Were people that had a tattoo more likely to have it or not? Yeah, which makes sense because it's a needle thing. So you could say like people with tattoos were more likely to have hepatitis C. Okay, and then last one here. So we're supposed to use the data from example 3 in the lesson. Suppose 5th grade class contains 117 girls, 125 boys. Did more boys than girls prefer lemony snicket? I think this is like a reading thing where they were reading the charts back here too, where they were like reading different books or whatever, and then they were supposed to pick which was their favorite book or which book they preferred. So we're supposed to figure out, I didn't even read it. Well, I did read it, but did more boys than girls prefer lemony snicket? Okay, so here, what we're going to have to do, because, so this one's a little different because we're in percentages. So we're looking at the lemony snicket stuff, and we're in percentages. So what you have to do to figure out specific numbers of boys and girls is you actually have to take these percentages times your number of each. So for like girls, they said there's 117 girls. Boys, there's 125. So you're actually going to want to figure out what specific number out of that total of 117 girls is 28%, and then what specific number out of 125 boys is 23%, and then see, like, compare those numbers after you did the calculation. So back here, we had girls was 28% preferred lemony snicket, boys was 23%. Well, like I said, we can't just go off of those percentages because we've got different numbers of girls and boys. So to figure out their actual specific numbers that preferred one or the other, you would take like your total girls number, so the 117 times your girls percentage as a decimal, so like times 128, and then you do the same thing for the boys, so your total boys number, 125, times your boys percentage, 23. So 117 times 0.28 is 32.76. 125 times 0.23 is 28.75. So looking at our stuff there, which, did more boys than girls prefer? Okay, did more boys or girls prefer it?
Girls.
The girls group, right? So it said, did more boys than girls? Well, no, because the girls one was higher. So you could say no, like about 33 girls preferred lemony snicket. Then about 29 boys. Something like that. Like I said, this stuff is mostly just reading tables and figuring out percentages and different things from tables. It shouldn't be too bad. Okay, so that's it. So book page assignment then, 392, 1 to 10. So working on those, like I said, it's mostly just chart stuff. Some of the charts are harder than others.